So I've gone ahead and written out the acceleration equation there. A, again, it's not moving, it's a pivot, so that's 0. And so C, the acceleration of C, if you look at the original picture, C is pivoting around D. So let me sketch that in here. There's D. And so it has acceleration of r omega squared going in. Okay, and so we already did that, but the r is 0.5. I'll just write omega CD squared, and it was 11.55. We'll calculate that later. I assumed alpha was counterclockwise, so r times alpha will be going this way. Okay, and so that will equal, okay, this part in brackets, again, is just C spinning around A. Okay, so let me draw that in. Here's that. Okay, so C spinning around A. There's always this r omega squared, so r was 1, and omega was 5. Okay, so that's this one going in. And we're given alpha was 3, and r is 1, and so it'll be this. R is 1 times alpha is 3. Okay, plus, okay, this is going to be perpendicular to the arm, and let's go ahead and figure this out right now. So it's 2 times the omega was 11.55, and the v relative was 2.6, and the directions were v rel was going up, and omega was going clockwise. So I am doing the right hand rule, and I get that it's going this way. Okay, so make sure you can do that. And again, this is C relative to A. I wrote D. C relative to A. That's what the camera sees. The camera spinning around A, and I'm just going to have to guess. Maybe I'll finally get one of these right. Let's say down. Okay, so I'll guess down. Okay, of A, C relative to A. Okay, so I'm going to go and make this all nice, multiply out the numbers, and come back. Okay, so I've gone ahead and multiplied all the numbers out, and I learned that we should do it on the inclined axis, so I went ahead and took that vertical 0.5 alpha CD and took cosine 30 and sine 30, and that 0.5 omega CD squared came out to 66.70, and I took cosine 30 and sine 30 of that as well, so I already got those components in red. And everything else I just multiplied out, and now we're ready to take components. I also highlighted in yellow the unknowns, and I notice again in the x direction there's an alpha CD unknown and an AC relative to A unknown, but in the y direction there's only an alpha CD unknown. So what I'm going to do is, because I'm lazy, I'm going to do that one first. Okay, so I'm going to do the y prime and up and to the right as positive. So anything in that direction. So we have going down to the left, so negative 0.433 alpha CD. This one is going up and to the right, plus 33.55 equals 3 up and to the right, plus 60.06 up and to the right, and let me solve for alpha CD and come back. So I've kept my streak alive. Alpha CD is negative 68.15. So I assumed the wrong direction. Let me look. I assumed counterclockwise. So alpha CD is in fact going clockwise. 68.15 radians per second squared. Okay, now that we know that, let's do the x components, and I'm taking downhill as positive, so 0.25 alpha CD, but I'm going to have to put in negative 68.15 for that. Okay, plus 57.77, that's going downhill, equals minus 25 going uphill. This does not have a component, plus A of C relative to A. I'll plug in for alpha CD and I'll solve for A, CA and see what comes out. Okay, so I solved for A of C relative to A sliding, and I got 65.7 meters per second squared. That wasn't asked for in this problem, but I might ask for that in the exam, so I thought I'd show you everything. Okay, so what was really asked for in this problem were omega CD and alpha CD, and that's what we have right here. Okay, so there you go, 2 relative motion problems with rotating frames. I hope this helps.